In this video, we're going to be doing application problems for solving systems of linear equations in 3 variables. Here we have the height time t of an object that is moving in a vertical line with constant acceleration a, and it's given by the position equation f equals 1/2 a t squared plus v naught t plus s naught. Now the height s is measured in feet and the acceleration a is measured in feet per second squared. T is measured in seconds, v naught is the initial velocity in feet per second at time t equals 0, and s naught is the initial height in feet. I'm going to find the values of a, v naught, and s naught when we have a height of 52 feet at 1 second, at 52 feet at 2 seconds, and 20 feet at 3 seconds. And we're going to interpret the results. So we can begin by writing a system of equations. So we'll look at each of the pieces right here and create equations from those. So we're going to plug in the 1 and set it equal to 52 for our first equation. And then we'll do the same for the second equation. We'll plug in the 2 and set it equal to 52. And then we'll plug in 3 and set it equal to 20 for our second equation. So we're going to go ahead and we'll work out our powers right here. So our first equation is going to be 1/2 a squared plus v naught plus s naught equals 52. Our second equation will be 1/2 a times 4 plus 2v naught plus s naught equals 52. And our third equation will be 1/2 a9 plus 3v naught plus s naught equals 20. Now, I really don't want to work with fractions, so how can we get rid of that? Well, we could multiply it by 2. So we multiply that one by 2, that would do that. The second equation, we have 1/2 times 4, which in and of itself is going to be no fraction. So we can leave that one alone. But 1/2 times 9 would still be a fraction, so we'll multiply that one by 2 as well. So that gives us 3 new fractions. So our first one is going to be a plus 2v naught plus 2s naught equals 104. Our second equation, half of 4 is 2, so 2a plus 2v naught plus s naught equals 52. And then our third equation will be 9a plus 3v naught, plus 6v naught plus 2s naught equals 40. So now we're ready to solve. So we're going to go ahead and we're going to get rid of our v naught. I think that's going to be the easiest, some of the easiest ones to get rid of. So we're going to do that first. So on this first one, I'm going to multiply everything by a -1. So we can get a -2 v naught there. So we get negative a minus 2v naught minus 2s naught minus 104. Then we'll multiply our bottom equation by a -3. And that's going to give us, or actually, we don't need to because the 2's are already matching, right? The 2's already match. And so that equation is stayed the same, 2a plus 2v naught plus s naught plus 52. So when we add these together, our s naught, or excuse me, our v naught are going to cancel out. And that's going to leave us with an a minus s naught equals -52. And so we're going to have a little parking lot area, so we're going to hold on to that equation that we'll come back to for later. So we're going to write that down. A minus s naught equals -52. All right, so now we need to incorporate the third equation because we already used the first equation and the second one, but we need to get rid of the third. So we're going to keep the 9. We'll keep our 9a plus 6v naught plus 2s naught equals 40. Okay, we're going to keep that. And then we're going to get rid of, here, we need this to be a -3, so that'll turn into a -6. So that equation is going to become a -6a minus 6v naught minus 3s naught equals a -156. So now we're ready to add those together. And our v naughts will cancel out like we want them to. And now it's going to leave us with a 3a minus s naught equals a -116. So we're going to put that in our parking lot as well. All right, so now we're going to look at our parking lot. And we notice that our s's are matching. So we can make those opposites simply by multiplying, let's say, our top equation, or excuse me, our bottom equation by a -1. So my top equation is going to stay the same, right? A minus s naught equals -52. The next bottom equation is going to change to -3a plus s naught equals a positive 116. So now when we add those together, we get negative 2a. Our S naught are going to cancel out. And when we add the negative 52 with the positive 116, that's going to give us a 64. So then from here, we'll just divide both sides by negative 2 and get a equals negative 32. So that is going to be our first solution. Now that we know what a is, we can plug that back in to this equation right there. So let's grab that equation, just a little asterisk right there. So a minus S naught equals negative 52. And we're going to plug in our negative 32 minus S naught equals negative 52. And so we plug that in. Now we're going to solve for S naught. So we're going to add 32 to both sides. And that's going to give me a negative S naught equals a negative 20. Well, I'll just divide by negative 1. Now it'll give me an S naught equals positive 20. So now we have a second solution. We have our S naught. We just need our V naught. So if we come back up to our original equations here, we want to go, gosh, which one was probably the easiest one to plug stuff into? Okay, so as we look, I'm thinking I probably plug it into this one right here. I feel like that might be the easiest one to plug it into. So I'm going to plug it into. I'm going to go ahead and let's give ourselves a little bit more space. All right, so we're going to plug this in to our A plus 2V naught plus 2S naught equals 104. So we're going to plug these in. All right, we're going to plug them into this equation right here. All right, so we've got negative 32, right, because that was our A value, plus 2V naught plus 2, and our S is a 20, and then equals 104. Okay, so negative 32 plus 2V naught plus 40 equals 104. I'll combine my like terms, and when I do that, I get 2V naught plus 8 equals 104. And now we're just solving for V naught. So we're going to subtract 8 from both sides and get 2V naught equals 96. Divide both sides by 2. And that's going to give us that V naught equals 48. 48. So now we've found all three of our pieces, right? So now that we have this, the solution results in a position equation. Okay, so our position equation is that S equals 1/2 of our A T squared plus our V naught of 48 plus our S naught, my bad, I missed a T, our V naught times T plus our S naught of 20, right? So we plugged in our pieces. Plugged in our pieces, and when we simplify this, we get S equals a negative 16T squared plus 48T plus 20. So this is our position equation right there. So what does that mean? So that implies, right, that implies that the object was thrown upward at an initial velocity of 48 feet per second from a height of 20 feet. So we were able to find our position equation. We were able to solve for our A, V sub naught, or V naught, and our S naught, and interpret those findings.